Hi, I'm an old guy and I do maths, and today we're looking at some further hyperbolic function. Um, there's going to be a series of these, which you'll see in the playlist. And what we've done is we've modified the basic hyperbola, which is y equals 1 over x. So what have we done? Well, we've added a 3 here and a 1 here. And what is the effect of this? Well, the effect of this is to move the asymptotes. Now, the asymptotes, just a reminder, are values that this function approaches but never reaches. And we'll deal with this one first. This expression down here tells us that our asymptote is going to be at x minus 3 instead of this y-axis. Now, why is that? Because in order to make this equal 0, we have to make x equal negative 3. So at x equals negative 3, this function ceases to make any sense. It's 1 over 0. Try it in your calculator. You'll see you won't get anywhere with it. Okay, so that's our vertical asymptote. Our horizontal asymptote is dictated by this. Now, you'll notice that here, there's no number out here, or we could put 0. Here there is a number. And what that does is it moves the asymptote that was the x-axis up to y equals 1. So the rule is do what this says. The rule here is make this equal 0, and you will find the asymptotes. Now, let's draw this thing in, roughly, and see what we're looking at. Now, it still occupies basically the first and the third quadrants. But we are going to get some intercepts. So I'll just draw this very, very roughly. We're going to have an intercept there, and we're going to have an intercept here. So we're going to have an x and a y intercept. And really, the artwork is not particularly important. What is important is finding these points and finding the asymptotes. Now, we found the asymptotes, so let's find these points. Now, in order to find this point, we simply make x equal 0. So we get 1 over 0 plus 3 plus 1. What does that give us? That gives us 1/3 plus 1, and that equals 1 and 1/3. And so this point here is 0, 1 and 1/3. That is our y-intercept found. Very, very simple. A tiny bit more complicated because it involves a little bit more algebra than we've just used, is to find the x-intercept here. Now, what that involves doing is making y equal 0. So we basically make this equation equal 0. So 1 over x plus 3 equals negative 1. So 1 is equal to negative 1 times x plus 3, so we'll multiply that up. 1 equals negative x minus 3. Move the 3 back over here. 4 equals negative x. X is going to equal negative 4. So this point here, I'll just run an arrow up to here, is negative 4, 0. And you can take in the algebra here. I hope it wasn't too fast. I've just run through it again. We make this equal 0, then we're trying to isolate x in one way or another. And essentially that's what I've done. I've done every step, so hopefully that makes sense to you. Now what we're going to do, just to check this, is we're going to put negative 4 into this. So this is 1 over negative 4 plus 3, which is 1 over negative 1, which is negative 1, plus 1 is 0. And that is that. We've found the asymptotes, we've found the points of intersection with the axes. That's really all we have to do for this one. If you want to, just to show that you know all about what you're doing, you can put a value, say 1 in here if you want, and find this point, just to demonstrate in case there's any dilation, which there isn't in this case. If it were dilated, there would be a number other than 1 here. We'll get into that in another video. Anyhow, I hope you found this video useful. If you did, please like and subscribe, and I'll see you next time. Bye.